So let's see what is differentiation. And differentiation is a mathematics topic, but however we need calculus is differentiation and integration extensively. For 12th we need this portion, so you need to learn it now so that I can start the next chapter. In mathematics, what is differentiation is you have a y-axis and you have an x-axis. You may have a function in a graph. It may be a linear function. A linear function is y is equal to x plus 1, or f of x is equal to x plus 3, or whatever. This can be plotted as a graph. A linear function in which if you want to do slope, it's dy by dx. A slope is determined by the change in the y coordinate to the change in the x coordinate, and that ratio is what is called differentiation, a dy by dx. This is supposing it's a linear function. It can even be a quadratic function where y is equal to x square plus 2 or something like that. And then in that case, the differentiation is doing a tangent for it. A tangent also is nothing but a slope, which is dy by dx again. But this is also tan theta. Therefore, tan theta is also slope. A dy by dx is also slope. And that is considered to be differentiation of y. A differentiation of y, the function. Differentiation of a function. So supposing you have a function y is equal to x to the power n, a general function, because the function may be linear, it may be quadratic, it may be cubical. So let's assign a general function x to the power n. A differentiation of dy by dx is n into x to the power n minus 1. The n comes forward and the power has to be reduced by 1, and that's differentiation of x to the power n, which is n into x to the power n minus 1. Therefore, a differentiation of x square is a 2x to the power 1, or a 2x. A differentiation of x cube will be 3 into x to the power 2. A differentiation of x to the power 4 will be 4 into x to the power 3. Bring this forward, reduce the power by 1. So this, what happens when it's mere x? You know, you're differentiating with respect to dx. This is x-axis and y-axis, dy by dx. The dx and dx gets cancelled and becomes 1. Therefore, differentiation of an x is just 1 with respect to x. Okay, then dy by dx of a constant will be 0. Because you cannot possibly do a constant in a graph. You have y-axis and x-axis. And so you can't obviously do a slope for a constant. So differentiation of a mere constant is 0. Differentiation of a 3 is 0, 4 is 0. Whereas with 2x, this is called constant. No, this is called coefficient. This becomes a linear function, a 2x. A 2 can be taken out and dx by dx will become 1. So the answer is 2. Therefore, differentiation of a 2x is 2. A differentiation of a 3x is 3. A differentiation of a 4x is 4. This cannot be ignored because they are called coefficients. A mere constant only is 0. So you understood all this. So supposing you have a big equation which is x cube plus 3x square plus 2x plus 1. When they ask you to differentiate with respect to x, you know, this becomes a 3x square. This becomes 3 to 6 because the 2x is the differentiation of x square, so 6x. A 2 into dx by dx is 2. A constant is always differentiated as 0. So thus you get the answer 3x square plus 6x plus 2. So you should know how to differentiate, and this is mathematics. And how is this applied in physics? In physics, there's no x-axis and y-axis. I mean, it's not called x and y. This y-axis is called displacement and x-axis is called time. And you know that for uniform motion, the body covers equal distance in equal interval of time. And the slope for this will be dx by dt. Unless in mathematics it was dy by dx, here it's dx by dt. And that is called velocity. A velocity is dx by dt. Doing a slope for displacement time graph, you get velocity. So this is a small intro how math is getting converted in the case of physics. And I'm going to continue with this topic today. So become clear with this just introduction.